Let's take a look at the routing table on router 1 right now. That'll definitely give us a clue as to what's going on. And again, don't worry about all these route types down here. We're going to get to those eventually in your studies. Right now, we're only concerned with the connected routes, which is a good thing because that's the only kind of route we have here on router 1. It's a connected route, but when router 1 wants to send packets to addresses on the 172.12.123.0/24 network, here it is. It's directly connected. It's ready to go. So router 1 has no trouble pinging routers 2 and 3 on that same subnet because they're all connected to it. So we're all good there. Now, a quick word here about our network before we send some more pings and our service provider cloud. This is Frame Relay that I use in our rack, and of course, your actual production lab probably uses something different. Frame Relay is no longer a topic on the CCNA exams, which is why I don't show you how we configure this, but we're just simulating a wide area network basically. So we've got routers 1, 2, and 3 to work with, and this is very much like a lot of networks out there in production, because what you'll have is like a headquarters and you'll have your hub routers there, and in different cities, different physical locations, you'll have your spokes. So that's what we're mimicking here. Now, let's go ahead and go over to 2, and I'm quite sure that we can ping 172.12.123.1 from there. We can, and let's do 3 from there, and we can. But did you notice that those exclamation points didn't come back quite as fast? If you did, I'm really impressed. But let's look at these round trip times. We usually don't look at this a lot with pings unless we're doing some really advanced troubleshooting. But notice here, minimum, average, and max. And it took about 65 milliseconds to get the job done with that ping. This one took roughly twice as long. And the only reason I'm showing you this is to impress something upon you that I'm going to hit you over the head with a couple of times, because it takes a little getting used to, but it's a very important concept when it comes to hub and spoke routing. And here is the deal. Traffic that goes from one spoke to another spoke does not go directly from spoke to spoke. Okay, and I know that sounds weird, but it's a lot better when it's illustrated. And here's the deal. When I sent those pings from router 2 to router 3, it didn't go through that cloud and go straight to router 3. Hub and spoke traffic, spoke to spoke traffic always goes through the hub. That's why it took a little longer for router 2 to ping router 3, twice as long actually, as it did for router 2 to ping router 1, because the pings that left router 2 went up to router 1, then back out router 1 to router 3, and then of course when the echoes were being returned, they went from 3 to 1 and then 1 to 2. So here's actually what happened there, and it's basically a two-step process in this situation with 2 spokes and 1 hub for 2 to send packets to 3. Everything's going to go through the hub, which is why, of course, in the real world and in a lab, you really want your more powerful router to be your hub router. I've seen some what we call EOL, that's end of life routers out at spoke locations, routers that Cisco no longer even supports, and that sounds horrible, but the thing is, at these locations, that's really all they needed. There was no reason to spend money on a brand new router for some of these spoke locations because they didn't handle much traffic. So that's the whole deal with hub and spoke and what we've got to be careful about. And I will go ahead and send some pings from here. And you can see those round trip times going from 3 to 1. It's about 65 milliseconds. But when we ping the other spoke, you can see that it took about twice as long. Not a huge amount of time in any case, but just want to hit you over the head with that spoke to spoke traffic is always going to go through the hub. I don't think that's going to hurt us in our static routing labs, but it sounds like something we might want to keep in mind for dynamic routing protocols. So now that we've gotten to this point, how about some loopback pinging? Let's go back over to our network. And we could ping 2 to 3 or 3 to 2, really doesn't matter. Let's go over to router 2 and we will try to ping. Actually, let's go to router 3. We're already there. We're over on router 3. Let's send some pings over to 2222 and see what happens. And you can have that first packet timeout every once in a while, even the second one when you're pinging something for the first time. And then after that, all of them go through. But 0 for 5 is not good. And you can see here, it looks like we're going to have the same situation. So let me bring the diagram back up actually. Why could router 3 ping 172.12.123.2 on router 2, but could not ping 2222 on the exact same router? And where exactly is the problem? You know, it's easy to assume that the problem is always on the local router, and a lot of times it is, but it could be a problem on a downstream router. Let's bring router 3 back up and we'll do a show IP route connected. Actually, we'll do a show IP route. Now this router is going to show you some local routes, and I'm going to go over those with you later. It's not even a topic as far as I've seen on the CCNA exam, but I want you to know about them. And I've purposely given us a mix of routers where some of them will have local routes, some of them will not, but we're pretty much ignoring them for right now. I want to concentrate on these connected entries. So let's do a show IP route connected. And that's still going to give us the local routes, which is fine. But the thing is, this router is looking to route packets to 2222. And it's going to look in this table, the IP routing table that we looked at first, the full table there, and it's looking for the best match. And frankly, just by looking at that, we can see that we don't have any kind of match because we don't see anything in there that even begins with a 2. So I want to introduce you though to a debug, and I have to give you a little dad lecture here. You have to be careful with debugs in production networks, especially this one, because it can literally give the router, or it's giving you so much information that you can't access the router. I kid you not, I've seen it happen. I've seen it happen in lab environments. I don't think it's going to happen here, but I want to give you that little lecture. And the other thing with our debugs is that we want to run them when things are running well also. But right now, our pings aren't going through, and the thing with the ping command is, it's telling us there's a problem. Let's revisit that for a second before we proceed. And you can see, ping 2222, and we get 5 timeouts. And we know, obviously, that is bad. But the thing is, it's not really telling us where the problem is. That's where world-class network admins keep digging. Anybody can send this ping and say, hey, we don't have connectivity. It's like, well, thanks, Sherlock. Clean that up for you. But the thing is, we don't know where the problem is. We don't know what the problem is. We think we do, but we don't know. And what I'm going to do right now is run debug IP packet. Very powerful debug. Then I'm going to send a ping to an address that we know we can successfully ping, because it's really important for you to know what a debug looks like when something's working well, so you have something to compare it to when it's not working well. Now, those of you with sensitive eyes might want to close your eyes for a few seconds, because we're going to get a lot of information out of this. Yep. And that's just with one simple ping, and a couple of screens of traffic there. I'm going to do a UAll. That is short for undebug all, by the way. I just say it's a Southern command, UAll, sir. So let's see up here. I see the word false a couple times, but that really isn't the issue here. What I do want to point out to you is that we've got the word sending. And that's the first thing we look for. Remember, this is our ping that went through. And what we're looking for is that the packets are actually going out. We're always looking for the word sending. And you see that exclamation point there. That's just one of the pings that came back. It's going to get mixed up when you have a debug. That's what we're looking for as far as the debug goes. So now I'm going to turn the debug back on and ping 2222 and see if we can spot what the issue is. Packet. And then ping 2222. And that does not look good. We do not have many certainties in our business. We can rarely say never or always, because there's almost always an exception. But the word unroutable in a return of a debug is always bad. So first I'm going to do a UAll here, and then at the beginning of our next video we're going to discuss why we're seeing this message, what we're going to do about it, and we will write our first host static route.